So this is what I was talking about when you have a complex number written in standard form. So we kind of introduced this on the last page. But again, standard form is going to be a plus bi, where a is the real numbers and bi is the imaginary part. And so as we look at the number system, we've got the real numbers, which is what you're used to. So that's like your integers, your fractions, variable, pi. I think this is supposed to be a pi when you're looking at numbers, not a variable. And then root 2. Those would be all examples. 6 is also an example of a real number. And then imaginary numbers are anything with your I. All right. And then pure imaginary numbers are as if you don't have a real part. So you only have the imaginary. So imaginary numbers have a real part and an imaginary part. Pure imaginary numbers only have an imaginary part. And real numbers only have the real part. So the imaginary part is 0. So what we're going to do is we're going to use those ideas in order to simplify. So the way we're going to do that is if I'm just adding and subtracting, I is like a variable. So if I'm trying to solve, I know that the 2x is the real part and the 10 is the real part. So these are our real parts. And that's an R. And this is our imaginary parts. And so as you look, one option is we just set the real parts equal to each other. So we're going 2x equals 10. So 2x equals 10. Those are the real parts. And we solve and we get 5. So x is 5. And for imaginary, we look at the imaginary parts, which is negative 7i and yi, and we solve for y by dividing both sides by I. So that's what they have in common. We're trying to get y all alone. So if I divide by I, the i's cancel out and you get y is equal to negative 7. So when we look at monitoring progress, it's the same idea. I'm looking for real. So the real part is the part in the beginning. So this would be x is equal to 9. There's nothing to solve, so this is my real part. If I look at the y, or the imaginary part, I get 3i is equal to negative yi. And then you solve by getting y all alone. So I'm going to get y by itself by dividing by negative I. And the reason I want the negative I is I'm trying to get y to be positive. So I get y is equal to, and then this is like negative 1. So 3 divided by negative 1 is negative 3, and the i's cancel out. And so this is my y part. When I look at 6, it's the same idea. I go real to real. So this is the real part. And I know that because it's in standard form. So I'm going to go 9 equals negative 2x. Sorry, that was my dog sneezing. And then this is 4yi and 3i. So those are the imaginary parts. And then you're going to solve. So as I solve, I'm trying to get x all alone. So I divide by negative 2. And so we get x is equal to either negative 9/2, or we can divide that out to get negative 4.5. And again, it doesn't matter. As long as your decimal comes out nice and clean, you can do either. When you're looking at the next one, we're trying to get y all alone. And so here's my y. And so I need to get rid of the 4 and the I. So I divide 4i out, divide 4i out. And so we're left with y. And then I divides out I, so we're left with 3/4. And so these would be my solutions for x and y in this case. So I think we'll just stop the video for this one.